of the IP will be the network ID, and the other part ID. So the host can be your computer, a router, a printer, or any device that is connected to that network. And remember, we have public network and private network. So a network does not just mean internet. A network can also be a local network where you don't need internet, but the computers are connected and files can be sent from one device to another device. Okay, so we learned about different classes, different classes of IPs. We learned that class A, the first bit of class A is a 0. Class B, the first 2 bits are 10. And then class C, we have 110, and then we have class D and E. And remember, class E was just for research purposes. So that's how we can be able to identify different IPs we have. And then we spoke about the idea of subnet. So a subnet mask is when we separate the network ID and the host ID in an IP address. That's where we mean by subnet. So subnet, we're going to basically separate those 2 IDs we have, the network ID and the host ID. All right. And then we also spoke about what is that? A broadcast address. So a broadcast address, we said, will be the address where all the host bits are set to 1. We're going to talk about that. So in a broadcast address, so we're going to take the part of the IP that is the host, that's determine the host ID. We're going to set everything to 1 in binary, obviously, which can be calculated in decimal numbers. In decimal numbers, 255. So when we have 255, it means every digit of that number in binary is 1. All right. So that was the broadcast address. Guys, can you please make sure you mute your mics? All right. So there's many types of addresses, and then spoke about how we can calculate this network address. Either you can calculate the network address, the broadcast address, or the number of addresses that can be available in a certain network. All right. So that's where we stopped yesterday. All right. So we're gonna let's look at an example here. Let's look at what we have here, where we have an example of an IP calculation. So I hope you can see that we can all see. Once again, let me make sure I am recording this meeting. Okay, perfect. All right, so let's look at this IP address here. So this IP address is so we have 172.16.10.1/16. All right. Is there anyone who knows what is the 16? What's the meaning of the 16? Does anyone know the meaning of the 16? Is there anyone who knows the meaning of the 16? Does anyone know the meaning of the 16? So in this case here, the IP, yes, are you responding to the question?
No.
All right. So in this case here, the IP address itself. So why is this not full screen? Sorry guys, I'm trying to pick up a pen here. There we go. So in this case here, the IP itself is 172.16.10.1. And this 16 here, right? It's not part of the IP, but it's an information that is giving us. So this prefix of 16 just means, you remember guys, or when we spoke about the type of IP address that we have yesterday, we spoke about the IPv4, which has 32-bit, the 32-bit bit IP. So this prefix here of 16 means that we have 16 bit for the network and 16 bit for the host. So we have 16 for the network and the rest will be for the host, because in total we need 32 bit. Because we need 32 bit, this means we have 16. So in this case, for example, here, can anybody tell us how many bits are we going to have for the host? How many are we going to have for the host? Anyone?
Sorry, can you please repeat the question?
I'm saying, in the case of this IP address given here, how many bits does the host has? In this case here, the host has 16. What about this case? Guys, what about this case? How many bits does the host has?
I'm gonna take a wild guess because I was not in the classes. Is it 8?
No. So here, remember just what I just said now. This prefix here means that we have 16 bits for the network. So here it means we're going to have 8 bits for the network. Right? Remember, we have a network ID and a host ID. So in this case, it happened that we had 16 and 16. All right, guys. So I'll repeat again, I'll ask again. How many do you think, because this 8 is the network ID. So in the network, we're gonna have 8 bits. What about the host in this case? What about the host part? How many are we gonna have? Guys, how many are we gonna have? Guys, why is this question difficult? Is the question difficult? Is it confusing?
Hi, can I just ask a question before I answer that question, right? So can we just go back to the top one where you circled with the 16? So is that referring to, you said 16 bits, that's referring to the network?
Yes, because remember the IP
Yes.
address.
And then if,
the IP address as a part, which is a network ID, and the other part is the the host. The host means your device. So one gives you the information of the network,
yes.
one gives you the device.
Yes, that's what I'm trying to understand. Which part on there is the information for the host and which part is for the network? That's what I'm not understanding. Sorry.
The first part is the network. The second part is the host.
Oh. So the second part would be where you circle the 16 when it says -16. Then before that, that would be for the host. Am I correct?
So,
okay. Great.
So this is the full IP, right? And if you have to put it if you have to put it in binary, right? If you have to put it in binary, here in this case, this prefix tell you that 16-bit will be occupied by the network. In this case, they tell you that 8-bit will be occupied by the network. So my question was, if in this case we had 16-bit occupied by the network, we also had 16-bit occupied by the host. Now, in this case, in the second case here, how many bits will the host occupy if the network is occupying 8-bit? Is the question clear now? Is the question clear now, guys?
I'm still slightly confused. I understand the host and I understand the network, but now your question is that you're asking if you said if 8 bits are occupied by the network, you're asking how many bits will be occupied by the host. So didn't you say before when we spoke just now that before the numbers before 8, just before the slash, is the numbers that are occupied by the host?
No.
No.
The IP itself is 172.16.10.1. That's the IP. And that's IP as the network and the host together. And then you have that /16, it's just a prefix to tell you the network will only occupy 16. So the answer comes back to IP. The IP needs to have a total, like in this case, we're talking about the IPv4, a total of 32 bits. That is the maximum. So because the network is already using 16, 32 minus 16 is 16. So that's why the host is going to occupy the rest of the 16. In this case, the network is using 8. It means that the host will have 24. Because 8 plus 24 will give us 32. Is it clear now?
Yes, that actually makes perfect sense now.
Yeah. So we need 32 bits in total. So the prefix here is to tell you how many bits does the network use. So now in this case, in this example here, we have 16 bits that are being used by the network. And for us to have 32, it means we need another 16. So the other 16 will be occupied by the host. All right. And we were told that it's a class B address. All right. So since it's a class B address, guys, remember now, this host here, we had this IP. Let me maybe write it again. So we have 172.16.10.1. All right. So this is what we have. So now it's a class B we set it a class B address. Now it means we have a certain range for that address. Okay, so it's fine. So here now we are asked to calculate the network address, the broadcast address, and the number of available addresses. So for you to calculate, this is the IP address, the 172.16 and everything, yeah, as it is. So if we convert this into binary numbers, 172 in binary, it gives you 10101100. So this is 172 in binary. All right. So this is 16 in binary. Okay. And this is 10 in binary. And obviously, this is 1 in binary. So this is just a conversion of this IP address in binary. All right. So now we have the subnet mask. Guys, remember what we said yesterday. So to get the subnet mask, what we do is we set every value of the network, we set it to 1. And every value of the host, we set it to 0. That is how you create a subnet. Do you get it, guys? So this means that in this case, we're going to have the first 16 bits, the network part, we're going to change everything to 1. And the second part, we have everything to 0. So this is going to be our subnet mask. All right. And then the network address. So now the network address will obviously, okay, we leave as the network address was. This is the network address. It means everything else, we keep it to 0 because the network address, we are just focused on the network part. Okay, so in the network address, we set the hosts to 0. Every value of the host will be 0. So in this case, for example, we'll have everything to 0. So if we want, let's say if we want to have it in decimal numbers. Okay, first of all, this one, the subnet mask in decimal numbers. Does anyone know what it's going to be? What will be the IP in decimal numbers if you have to give it back, turn it back in decimal numbers? Anybody knows? What's the maximum number an 8-bit can occupy? It's 255. So this is 255. 255. So this IP will be 255, 255, and then obviously 0, 0. So this is the subnet mask IP that we're going to have. So the network IP here, obviously, we have what? What is this, guys? What is the network IP? What will be this, guys? What will be the value? Can anybody tell me what will be the network IP? The full network IP?
$172.
Yes, no, give me the full IP, network IP. You're on the right track. Yeah, you can give me the full IP, the full network IP. You are on the right track.
Also, like even after dot.
Yes, the full IP. Yeah.
16. 172,16.
And then, so the
Then
full
0,
network,
0.
yes, the full network IP will be 172.16. Dot, this part will be 0. Dot, this part 0. So that will be our full network ID, which means that this address will identify the entire subnet, not a specific device. So this is why if I come to your house, there is 5 computers. When I get the IP address of all those computers in the network, they will all have the same network IP, the first part of the IP, and the second part, which will be the host, which will depend on each device. So each device will have its own host part of the IP. Do you understand that, guys? So this is why an IP address can lead you to a certain network first, which network is being used. So if you're connected to my Wi-Fi, we all have the same first part of the IP, and then the second part will be based on our devices. You understand, guys? So from this IP address here, we can generate what's the subnet mask of this IP, what's the network IP, and then the last one will be the broadcast IP. To get a broadcast IP, what we do, we don't change anything on the network side, but on the device side, remember now the device side needs to have unique IDs. But now, because here we're dealing with a broadcast address, so we change all the values to 1 on the host side. So when we change all the values to 1, it means we're going to have 172 here, we're going to have 16, and then this will be 255, 255. All right. So now in this case, we have the 2 most important IPs, which are reserved IPs. We have the network IP and the broadcast IP. So these IPs can be used for special need. You want to send a certain information on a certain network, or you want to do something, you do that. You want to send something in a certain for certain devices in a certain network, you use these 2. So these 2 IP obviously will be reserved. So now here, it means the broadcast IP is the address which can be used to send the message to all the hosts in the subnet. This is exactly what an hacker will do if the hacker wants to hack a certain company, because they will just use the broadcast address, affect all the computer in a certain organization. All right. So now the numbers of IP that can be available that we can create here. Guys, remember now here, this is what you are given, this is what you have. Now you want to see how many IPs you can have in this organization. So the numbers of IP, obviously the formula, it's 2 to the power n, and n should be the number of host bit. So the number of host bits, what is this? We have 16. Remember to get the 32-bit. In this case, we were going to be using 24-bit. So because we have 16, we're going to go 2 to the power 16. But if it was a 24, you're going to say 2 to the power 24. So in this case, we go 2 to the power 16, which will give us 65,536. So this is the total numbers of IPs that we're going to have. Now, this is the total that we can have in this organization. But the total that are available are only 2 to the power 16, which is this, minus 2. Guys, why do we minus 2 IPs to get the available IP addresses? Why do we minus 2? Can anybody tell us why do we minus 2?
I think one is for the broadcast address,
and
then the other should be for the network address.
Perfect. Remember, those 2 are reserved. The broadcast and the network. So that's why we -2. That's why the range will start from 172.16.0.1. It's not going to start from 0 because 0 is already reserved for network. And 255 is also reserved for broadcast. That's why we get to 254. You understand? So that will be the range. So from this IP to this IP, that will be the total range of what we can have. You understand, guys? So that's easy. So that means you can even calculate for this one as well. If you want to calculate, you do the same thing, same process. So that's how you calculate how the numbers of IPs will be. So just to summarize that, what you're going to have. So basically the network IP. So you can have a network IP in this case. You will have your broadcast IP address. So your network address, remember you take your IP and you change all the host side. You change everything to 00. You take the broadcast address, you change all the host sides to 111. That will give you a 255. And then you take the number of IP address, which will be 2 to the power of the number of host bit. And then the number of available addresses will obviously be the numbers of IP addresses -2. And then the range will obviously be from after the first one to the last number, but you -1. All right. Any question on this? Anything confusing? I hope everyone understands this part. Okay, so obviously this is the reason why we go to the concept of subnetting. So subnetting, what does subnetting mean? Subnetting is just means that we instead of using all the range of the IPs, we can actually create a certain group. Just you take a small range of the what you call that, of the IP available, so we don't waste the IPs. So subnetting is one of the most important concepts in networking because it solves multiple problems that can arise with large networks, you know. So it's going to help us to get, I can say, an efficient IP address use, right? So if you don't subnet, what will happen is that an organization that is given, for example, a class A or class B network might have millions of addresses, but maybe they only need a few thousand addresses. So when you look at an example of what we did there, we had 65,534 available IPs, but maybe this organization only has 200 devices. That means the rest of those devices, like 65,334 addresses, are just wasted. It means nobody else can use them. So we've just wasted them. All right. So that's why subnetting will allow us to break a large block into smaller, right? Into smaller blocks. So this will help to reduce the network congestion so that we can divide the network into smaller broadcast domain. You know, instead of us having one broadcast domain, because remember now, when you don't subnet, it means that if you're using the broadcast address, remember now, how many IPs do you have? Now, imagine if you want to send a message, how slow is your system going to be? Because your system is sending that, your system thinks that it needs to send to 65,000 computers while you just have 50 computers. All right, so that's why we need to use subnetting. All right, so it's going to help with better network management as well, and making sure that your system is secure. All right, so for you to understand what subnetting is, understand subnetting is just getting to a point where you reduce the numbers of IPs that you use in your network so that your system thinks that it doesn't have to use all the available IPs, but it's restricted in that way because you need to save your IP addresses. That will help you It's going to reduce all the broadcast traffic and improve your security, as I've said. And yeah, so that will be one of the methods used there. All right, so let's talk about the concept of network communication. So when we talk about network communication, this referred to how information are transferred from one device to another device. You need to understand that two computers are connected through a network, which can be through a cable or a wireless connection or any type of connection that you have there. Okay, so network communication is just the whole process of exchanging data. The data can be pictures, videos, files, any type of data, you name it, right? So when we talk about network communication, what we mean by that is exchanging those data between two or more devices. That can be computers, phones, servers, Internet of Things. So all these data are being transferred using a network. So the network can be either cables or we have Wi-Fi, fiber, satellites. Okay, so that is what we call network communication. So an example can be we have two computers. Files can be transferred between two computers through a cable. So that is the simplest form of networking. So in this type can be called peer-to-peer. So a peer-to-peer network is when we have a computer, you plug it to another computer. So when you have your phone, you plug it to your laptop, you are transferring files. That is a type of network. Okay, so you can connect computers using the Ethernet cables, and then you can assign even IP addresses to see how you can manage that. So this is kind of a direct communication there. And then you can have a network through a router, which means in this case, we don't have a cable like in the first case. We don't have a cable connecting these computers, but we have a router. So a router or a switch, which means that we have multiple computers that will form a network. So this is an example of what we call the LAN, the local network, local area network. So a router or a switch can act as a central hub, which means that everyone is connected to the router, and then this is how devices, each computer will connect to to communicate with other computers. The computer will just have to connect to that router or to that switch. So this type of network can be used, for example, in an office, where computers will be connected to a central switch or router so that people can share files, So you see that, for example, with printers, So remember now, in this case, it doesn't really need to be connected to the internet. You have the type of router where you create a certain network where devices can connect, such as printers and that. No need really for internet, as long as they are all connected to the same wireless network. All right, so, and then you can have a type of network where now it has to go through the internet. So you have a computer which is downloading files through the internet. So a computer is downloading files from a website, for example. So in this case, the computer must connect to the internet through an internet service provider. Okay, so the internet service provider will connect the computer to the web server where the files are stored. That's exactly what is happening. For example, now we're having this meeting. We are using Microsoft Teams. It means that from my computer, from using the internet, so my internet provider is connected to the server of Microsoft Teams, and all the information. That's how the communication is going. So from my computer to their server, and to your computer, that's how the communication is happening. So data is being exchanged using IP addresses. We have the DNS, which is the domain name system. When you see the name of the website, that's why you cannot have two websites with the same name. All right. And then the protocol that we are using is your HTTPS or HTTP. That's why you can see the website, any website, before there's the 3 W's, you will see HTTPS or HTTP. So that is the protocol being used. So, for example, if you open google.com, your request goes to Google server, the server sends back the web page, and then your browser will display it. All right, so this is one of the type of network communication. So the internet is the largest network because we have millions of computers, millions of network connected to others. All right, so that's how things have become now. With the internet, you can see how the whole world has become a very small village. Something can happen. You can sell a product from South Africa, you sell it to China, from anywhere around the world. You can communicate with people using a network, the internet. So the internet is the best invention since the 1969. So it's the best thing. Okay. So the way information are being transferred or data being transferred, it's exactly the same way when we look at a delivery process. If you have a certain item that you need to send somewhere, so you basically take that item, maybe you have it packed, right? So you take your package and then you get maybe to the post office, and then the post office will take it to whatever flight that is going to take it to a different country or to a different town. And when it gets there, it goes to the post office on the other side. They take the package again, and then they take the item wherever they had to take it. So that's the same way how information also are transferred in computers, because we have computers that have the data and then taken to a gateway router. From the gateway router, the internet is considered to be that flight that will take it to a different location. So the internet take it, and then there's a gateway that will receive it, unpack the data, and send it to the receiver of those data. Okay, so the same way we have what you call that. The same way we have these packages that are delivered from distribution centers to another distribution center until it gets to the destination. The same way when we take data, a packet of data will reach the gateway router through a certain network. And then after receiving the packet, the gateway will take that packet, and using the internet, it's going to send the packets to different routers based on the destination address. So when we look in this case, so we have an item creation, which in this case is a data generation. So that item or that data using the network, those data can be transferred. Okay, so when we talk about the way you can take an item and pack it into a box and send it, in this case, when we talk about computers, the data is encapsulated into packets. Each packet will get like an header with the source, the destination IP address, the sequence number, and some of the information that will determine where this data is going. Understand? So that's how data are being transferred. All right. So what is, when we're talking about these gateway routers, right? So what is What is a gateway? So when when we talk about gateway, what we mean, the gateway is just a device, right? And sometimes it can just be a software depending on what services you are using, because sometimes all the service you are using through the cloud, right? So it's just a device or a software that can connect two different networks and allow data to flow, right? So this is usually called the internetwork connector or protocol converter. So you must think about it like a door to door, a door to another network. So if your own PC, or maybe on a private network, want to access Google server on the internet, so the data must pass through the gateway. And in this case, can anybody tell us what will be the gateway? If you're at home, you want to access Google server, you want to search Google, what is the gateway? Can anybody tell us what's the gateway? What gateway are you going to use? Guys, it's in front of you, it's on the screen. What gateway take the information from your computer to the internet?
It's a device.
Which device? An example is your router. Your router at home, the device that gives you the internet. That's the gateway that we're talking about. It's the router that you have at home, so which will take the information from your computer to the internet. So the router, remember now, this router will have an IP address. Do you see that, guys? Now, looking at this, guys, looking at this now, what do you notice? So let's say, for example, we have okay, I want to look in, give you a scenario here, right? So let's say this PC is used by Google. So Google is using this PC, and then she's searching for something on the internet. And then we have PC2, which is being used by Precious. Right? So now this is Precious router. This is Google's router. Now, you look, when you have this information about these two people, but they tell you these two people, each one of them is in their own room, right? And doing research. They are students, obviously. So what's in common between Precious and Google? According to what you have, just by looking at how they are connected to the internet, can anybody tell us, what do you see, what is in common between these two people?
IP
What in,
address.
sorry?
Isn't it the IP address without the proxy?
Yeah. What's in common between Precious and Google? What can you tell us about Precious and Google? What do you know about them? Looking at how they are being connected to the internet.
They are using routers.
Okay, we know they are using routers. Looking for something else.
Are they connected to the same network? But it looks like they're connected to the same internet, or would it be the same network?
Yes, that's exactly what's in common with them. What's in common
Oh,
with them is, despite the fact that the different routers, they are connected to the same network. That means maybe they are in the same rails, but each one of them maybe have their own router, but that router is getting internet from the same network. You can see the IP address, the network part is the same. So these tell you that Precious and Google are connected to the same network. Because this part is the host, that means the device. The reason why it's different because Precious is using Precious is using what? She's using router 2 and Google is using router 1. So this is the host. This is the router ID. Right? So that's the thing. That's what an IP address can tell you about someone, right? You can even see it. Each website that you see there, you see it www something something, but that website has an IP address. So if you can get the IP address of that website, you can easily find two people with two different websites and see they all have the same hosting company. They are all hosting their website through the same companies. Why? Because those websites have that IP address. That's a similarity. All right, so your gateway is usually your router. So that is your gateway. So, okay, so guys, that's how simple this can be. So from your gateway, now the next thing will be your basic architecture in terms of how your network is connected, right? So when we look at that, when we have, for example, in a data center network, the network inside the whole enterprise data center can support different services, like in terms of the application that they are doing. So let's say we have Office Area 1, Office Area 2, Office Area 3. So this whole system here, maybe they are all connected to the same internet, right? So there's a communication that are happening in the company internally and externally. So we will have, in this network, we will have many devices involved. Obviously, you have all the computers. You will have firewalls. Firewalls will be for security. You have all the switches and routers. Uh, you can have, this company may have servers, right? So, uh, so thinking about it now, the network in this company can be so overloaded because the network needs to be able to support every service in the company, which means it involves all the applications, emails, databases that they have, if they have in terms of the devices, if they have storage servers, so this network needs to be able to support all these services. Sorry. All right, so obviously the key component of this network will be the routers or the switches, which will connect all the hosts, which means PCs, printers, phones, you understand? So all the Wi-Fi APs, which is the access point in that office, in the office areas. So those are the switches. So an employee's, for example, computer which is plugged into a certain access switch needs to be managed by the whole architecture of this organization. Okay, so you have all your routers. The routers need to be strong enough. So they need to be a certain network. For example, you look at a university, you take any type of university, you see how big. Okay, guys, let's, as in closing, is there anybody who has more than 2 routers in the house, in the home, to connect to the internet? Anybody who has more than 2? Okay, all right. So, is there anyone who has noticed in the home there is a difference of how strong the internet is depending on the room where you are? Anybody with that problem?
Yeah.
Yes, sir.
So now, yes. So now, how do you explain that when you get to university, you go, for example, to the library, you have internet. You go to a certain venue, you still have internet. Obviously, some universities or some part of the universities, the network is really slow. Some part it's a bit stronger. So where is the router? When the university goes to a certain provider of internet, they subscribe. In what room of the university? Where is the router at the university? Where do you think is the router?
I think there are many routers.
Yeah, that's what people usually think. What you can observe on your campus or anywhere where you are in a big organization, you will notice sometimes in a passage you see a small device, usually attached to the ceiling, right? And people call it a router. You see what I'm talking about? Anybody see what I'm talking about?
Yes,
You see a
yes,
certain device maybe on the wall somewhere, and then every time you get close to it, your internet is good.
yes.
Yes, so that is not a router. So when you look at big organization like that, you have devices that are they call them controllers. So those are where the internet is received. For example, at university, it can be in some building somewhere. And then that device will now have to be connected to other devices that you see somewhere in the wall, on the ceiling, and somewhere. Those are what we call APs, the access points. So those ones are just extending the network. So what they do is they connect to the controller and then they provide the internet for a certain range. So that's why you are on your campus on certain areas. The internet is really bad. Why? Because you are too far from an access point. So those are not routers; those are access points. So that is what now you see in a big organization like what we're talking about here. Maybe in all these office areas, yeah, you have to see where to place the access point so that when people come to this company, wherever they are, the internet is as good as it should be. All right. So the next time you see that, you will see, okay, you see on campus like, oh, this is not a router, this is just an access point. Yeah. So that device cannot work without a controller in some room in university. So that device does not provide the internet, but it just extends it to a certain range. All right, guys. Yeah, that will be all for today. I will Have a great weekend. I will see you on Tuesday. All right, bye guys. If there's anything you want to know, but I will send a message regarding a few concerns that people have asked. I will send it on the group. I'm just waiting for confirmation. Yeah, but anyway, all right. If you have any question, you can send me a message anytime. All right,
Sir,
guys. Yes.
before you end,